So the title of our talk is called Beyond Page Level Metrics. And my name is Brewer. As Steve said, I've been working on web performance stuff for a little while now, since 2001. I worked at this little startup that got acquired by Gomez, the synthetic monitoring company, and worked for them for a bunch of years, and then for CompuWare for a little while. As Steve said, I started a company called LogNormal with Philip. So the two of us did this real user measurement startup for a little while, and then we joined SOSTA. And now we're part of SOSTA. We work on a RUM product at SOSTA called Impulse. So starting out in monitoring back in 2001, a lot's changed over the years. And the thing that I'm spending my time on, and Phil's spending most of his time on now, is really focusing on real user measurement and extracting as much as we can get out of that.
Right. And my name's Philip. As Buddy said, I started LogNormal with him. Based on Boomerang, and I worked on Boomerang when I was at Yahoo working with Steve. So got a bit of history in working with web performance. I've always been in the RUM field, unlike Buddy, who also worked in the synthetic field. So we kind of look at these problems from both ends and try and figure out the best kind of data to look at and how to present it to users. So before we start, so this is a tutorial, and there is source code you guys can get if you're interested. There's two repositories. They're both under github.com/lognormal. I think the top two on the page are the ones you're looking at. You can go ahead and download the zip if you want. You can go ahead and clone the repository, or you can just sit back and listen. Either way, I'm going to show some of the source code on screen, and we're going to talk through them. All right. So we're going to jump right in. Don't want to spend too much time introducing ourselves. So what does a page load look like? For a long time, we've cared about how long a page takes to load, but what does that page load actually look like on the network? So this here's a waterfall I took from Chrome for the Velocity schedule page for today. Right at the top, you see the initial page loading, and before that page load completes, other resources start downloading in parallel. You also see conversion.js, which has an error there. That's because I had an ad blocker on while I was downloading this. So I wanted to show you this particular waterfall with these errors and stuff, because typically when you have a real user, you're going to have various errors that you don't know about that you can't necessarily measure in the lab. There's all kinds of scenarios that you need to look at, and these are the kind of waterfalls that may or may not show up in the lab, in the real world. So you're going to get many different types of waterfalls, and we want to actually measure all of those and try and get an understanding of how our page behaves for real users. So we saw there's a lot of resources downloaded in parallel. Now, different browsers handle that parallelization differently. And there's this great site called Browser Scope. You can go to it right now and have a look at it. Shows you, it actually runs tests on different browsers, and it'll tell you which browsers support what kind of features. So in this case, looking at the network tab, we see that a lot of these browsers support the perf timing API that includes navigation timing, resource timing, user timing. Then it also tells you how many connections to a single host a browser will make in parallel. So you see that IE11 will make 13 parallel connections to a given host, while Chrome 32 will only make 6. So if you have a lot of resources on the same domain, IE11 can download 13 of them in parallel versus Chrome 32, which will download 6. And I think for mobile browsers, there's no mobile, well, there's BlackBerry here, but some mobile browsers will reduce the number of connections because they're going over mobile networks, so they don't want to use as much parallelization. Whether scripts can download in parallel, whether scripts and CSS can download in parallel, those are all interesting things. Now, we have different users, and therefore we want to measure all of these users differently to find out, well, are we actually getting the right impact from our page design, right? Now, we also want to know which of these components affect perceived latency. So when we say perceived latency, it's really how long does the user think it took the page to load, or how long did the user think it took for something they were trying to get to actually become available to them. The user clicked on a link, and something showed up on screen. Maybe the whole page didn't load. Maybe they only cared about something that was above the fold, and that loaded. how long did it take for that? How long did it take for them to carry out their task? Typically, when we look at this waterfall, a lot of the scripts and stuff at the top, they're really invisible to the user, right? They're downloading over the network, but there's nothing for the user to see. So until your CSS has loaded, until some scripts that actually provide functionality, until content is loaded, there's nothing for the user to see. And we want to be able to measure that. So we want to be able to point at specific points within the page and say, when did this happen, and how long did that take from the time the user initiated that request, or if the user is performing a long task, how long did they take to get from point A to point B? Are any of these resources single points of failure? Anyone have guesses on what kind of resources, apart from what I mentioned here? So static JavaScript and CSS at the top. But if you depend on some JavaScript for functionality on your page, right, and that JavaScript doesn't load, and the user's clicking on links but nothing's happening, that's a single point of failure, right? Even if that was loaded asynchronously. So these are the default ones. If you have a script node at the top and you have a DNS failure, or that server's just busy and taking a long time to load, your page is going to not render until that actually comes through. And the same with CSS. It's not going to render anything, so the user's going to be looking at a blank screen for a long time. When I was flying over here from Boston, the airplane had Wi-Fi, but some pages wouldn't load. So CSS wouldn't load on some pages. So I was staring at a blank screen for a while until I hit escape to actually say, I don't care for the CSS, just show me the content, right? But when the page actually shows up, it's completely not what I'm used to seeing, and I have to figure out where all the components are again. So those are things that we'd like to measure, and we'd like to use browser APIs to measure. Are they actually happening to our site in the real world, and what can we do about that?
And yeah, so, you can get some of this stuff already in terms of the actual data points, right? You can get it been able to get it from synthetic monitoring for many years. So why do we need this RUM thing? Why does it matter? What's the motivation behind trying to switch from the way that we used to measure things to a different way of measuring, when a lot of the stuff that we've discussed already is the same type of data? And really, it's because we're focused on the user experience, right? And it used to be that prior to the APIs that we're going to go into today showing up, the only way to actually gain any insight was by simulating those interactions. You couldn't actually measure what real people were doing back in, when a lot of the synthetic tools first came around. And synthetic has its virtues, right? There are great uses for it, but it also has constraints and blind spots. Some of them being location issues, right? So you're going to get a lot of data about what the user experience might be in San Francisco, in London, and in Paris, but not necessarily what it's going to be like in Gilroy and Tellisford and Ez, in these more residential locations where you still have users connecting to your website from. And then obviously, everybody's dealt with this. Philip was dealing with this on the flight over, apparently, from Boston, right? Fast connections versus slow connections. When I'm at home on my very well-managed, broadband residential internet link, I have really, fast latencies, high broadband, pretty good experience. But when I'm at Starbucks trying to get something done, or on some of these flights, or at conferences sometimes, I have slow connections, and I have to deal with that. And it's important as a provider of content, regardless of what type of site you have, whether it's e-commerce or media or just informational, to take that into account, right? To understand what the constraints are that your users are dealing with. So by measuring your users, you can get that information. And then the other one is, there's common browsers, and then there's, uncommon browsers, right? So there's the IE, Chrome, Firefox, but then especially if you do, business or have users internationally, there's Yandex and 360 and Sogo, and then there's like Maxthon and Iceweasel and all these other ones that may matter to you depending on who your users are. And in fact, we looked over all of our data just, for kicks last Thanksgiving, right? So we looked at Thanksgiving Day through Cyber Monday, just over that weekend, and we looked at, we counted up how many browser vendors and major version that we saw, and what we got back was 527, which is quite a lot, right? Like the only way that you're going to get that diversity of data is by actually measuring your users and taking into account the diversity of your users. So, the bottom line is that your users are not the same as, the servers that run the simulations, right? I mean, you've got everything from like that guy over there with the cream-colored T-shirt that looks like he's asleep, to the guy in the back on the phone, the dude who's like picking his nose in the middle, like all laptops and cellular, right? So there's just a lot of diversity, and it's important to take all that into account. And again, it used to be it was really hard to get this information. Yahoo was one of the first companies that started taking this approach with the work that Steve and that Philip were doing. And but even then, you were limited in terms of the insight that you could get. You could get basically page load time information, but what's happened in the intervening years is the major browser vendors have implemented support for all these APIs. And one of the reasons that we wanted to do this talk was because we felt like, and yet we'll still talk about this, but we won't spend a long time on it, navigation timing is pretty well understood at this point. It's the one that gives you page-level metrics.
So let's just see who actually knows about navigation timing. All right.
Yeah. So that's pretty good percentage of the room, right? So that's the one that gives you page-level metrics. And you get a lot of page-level metrics, as it turns out. Everything from the point where you first press enter on the location bar or you click the link, all the way to actually information about the unload event, and everything that happens in between, and it's widely available. It's available on recent versions of IE, recent versions of Firefox, almost every version of Chrome, recent versions of Opera, and even pretty wide availability now on mobile browsers as well, which is pretty key because of the amount of noise and diversity that mobile users experience in their connection speeds. Obviously, the one that's really glaringly missing that everyone points out every year at Velocity is Safari, still not part of it. So if anyone knows anyone on the Apple team, I think there's actually a petition on change.org,
there is.
that Mehdi put up from Catchpoint. So go look that one up. It's on change.org and vote for Safari. Yeah, Steve?
There was Ilya tweeted something about a month ago that some Safari developer was asking questions about the nav timing implementation. And so that might be a hint.
That's awesome.
Yeah.
So Steve just pointed out that Ilya, who's on the Chrome team and also really active with the W3C Web Performance Working Group, got an email from someone on the Safari team who was asking about navigation timing implementation. So that's pretty cool. Can't wait to see that. Yeah, for sure. So anyway, widely available and pretty easy to use, right? So it's in the DOM. You call the performance.timing object, and it has a bunch of attributes on it. For example, if you wanted to measure just how long it took to run the load event, you could grab load event end and load event start, do the subtraction, and throw it into a variable. Did you have any examples, code examples of this?
Not for nav timing.
Not for nav. Okay, so yeah. So that's navigation timing, right? Page-level metrics. But what's really interesting is now some of these other APIs, like the resource timing API, are becoming pretty widely available to the point that you can really use it. So you get information about how long it took to load the entire object. But in many cases, you also get more detailed information than that. Right? So you get information about how long it took to redirect over to the object, if that was involved, how long it took to perform DNS on that particular object, irrespective of how long it took for the page, if it was on a different host, connection information, and that type of stuff. And again, it's available on recent IE, Chrome, Opera, as well as even some mobile devices. Did you want to take over?
Yeah. So resource timing gets us some interesting things. Andy, for example, wrote a little bookmarklet that can generate a waterfall for any page using resource timing information. I think we can show that right now, right?
Yeah.
And it's pretty easy to use. I just open that bookmarklet, and it shows me how much time it took the base page to load and how much time it took each resource. There's actually only one image on that, and it tells me, well, it doesn't tell me numbers, but Andy? Somebody want to submit a pull request, Andy accepts them. He accepted one from me yesterday. So.
Did some of them not show up because they didn't catch?
So there actually isn't anything else. There's one image on this page, but maybe I'll get a larger page. So yeah, that's. Oh yeah, that's right. Well, velocity. All right, that's more interesting. Right. It would still be nice if some of the resources started loading before the whole page completed, right? But that's pretty good anyway. So good work, Andy, and thanks for giving us something to talk about. So you have that waterfall. Go ahead and clone that repository and start contributing to it, because we could get more people using it and more people knowing about it. We could also do a cache hit ratio, right? Because resources that do happen to be in cache tend to show up with a 0 load time. So the start and end of the resource is the same time. And that's a good way of telling whether something loaded from cache or not. You can also identify problem resources. So, for example, looking at the slowest resource on the page, or seeing if any one particular resource is taking up most of your page load time or something. Those are things you can get from the resource timing API. There are some things to know about using resource timing. So for privacy reasons, doing measurements across domains is not allowed by default. So for example, if you're velocityconf.com and you have a CDN that's got a different name, CDN, I think they use cdn.o'reilly.net, you can't necessarily measure the full timing information of resources from that server because it's not the same server. But if you are if you own that CDN and you want to allow your site to measure it, what you could do is put in a header saying timing allow origin and the origin host name. So I could say timing allow origin velocityconf.com, and then any page loading from velocityconf will be allowed to measure timings from my CDN. Right? As a third-party script author, so at SoStar we provide a third-party script. We actually want all of our customers to be able to measure our script. So we say timing allow origin star, which means anyone whose site host points to our JavaScript can actually measure our JavaScript. Now, I said you can't measure. There are some things you can measure and some things you can't. So by default, you will only be allowed to measure when the request started and when everything was available. All right? So start time to response end. But if you allow this, then you also get how long it took to make a TCP connection, how long it took to do the DNS lookup, SSL negotiation, etc. The reason that's not allowed is because, well, if it were allowed across domain, then you could figure out whether DNS was cached. So that means that person visited that site before, or whether TCP connection was already open, etc. And that allows various security attacks to happen. So this way, you only allow people that you know are friendly towards you to actually measure. Right?
And I think you can use Andy's bookmarklet to really easily tell which of your third parties supports cores, right?
Right. So if the bookmarklet doesn't show something, or rather doesn't show the individual components of the load time, then you know that it's they don't have a cores header. So, sorry? Gray bars. So go ahead and petition all third parties to include this header so that we can measure them from our sites and know if they're actually hurting our sites. There are some limitations, though. The biggest one is it doesn't report on errors. So if a resource returned a 404 or 403 or 500 or timed out, we don't know about that. So this is actually a problem because one of the things we care about is which of those resources was causing our page to take a long time to load. So if our page took 30 seconds and 20 seconds of that was spent waiting for a particular image that timed out, we want to know that. But that doesn't actually show up in resource timing. So we might want to get some changes to the actual API. Also, it doesn't tell you if a response was a 304 or 200. So 304s and 200s are, I think, the only two that actually get a response, get an entry in resource timing. But it would be nice to tell which of the two it was because one of them actually has content, the other only has headers. Right? But we still can do a few tricks. So I think I'll show the example now.
Sure.
All right, so I've got a quick example here. It's just a web page, contains one image, one broken image, and a couple of CSS and JavaScript files. And I click Show Resources, and I'm just showing start time and duration for all of them. So the first one is the CSS, then JavaScript, then the image. Why are all of these fonts showing up? Do you have any extensions?
No, I don't think so.
All right. So all of that, and then we did a little bit of a trick for this broken image. You see it says not listed here. So a bit of a trick what I'm doing here is I use getElementsByTagName to run through all the tags that could potentially pull in remote resources, so images, scripts, links, objects, iframes, etc. And if anything shows up in that but does not show up in resource timing, then it's highly likely that that was a resource that had an error, right, and therefore did not show up in resource timing. So I can look through all of those resources and say, all right, why don't these show up? Maybe I need to do some further testing of those particular resources. So it's some way of finding out, getting around that issue where we don't actually have, we don't show errors. You see this one here. That's actually the Boomerang script, which has a far future expires header. So duration is 0 there because it was returned from cache, right? Anyone want to see the source code? Hands? A few. So ignore the top part. That's actually loading. We have the CSS here, JavaScript here. There's a script to load JavaScript in an iframe. Then some more JavaScript here. But essentially, the code that goes through the resource timing is here. So I use it's pretty small though. Yeah. So window.performance.getEntries, which returns all entries, all resources, all marks, all measures, etc. And then I essentially look for resource.name, resource.startTime, and resource.duration. Right? So if we look back at that image that we had up a little while ago, this one, you can see all of the different components. So the start time right at the start, which is when the request actually was initiated. Then there's a bunch of others, redirect start. So if there was a 301 or a 302, you'd actually have a redirect start and a redirect end, saying this is how long it took to go through the entire redirect chain. Right? Now again, this is subject to cross-origin policies. So if any of those components in the redirect chain did not have a cause header, that may not show up there. Right? Then there's fetch start, which is when it actually started, made the request, the final request for getting the resource. Domain lookup start and end for DNS, and finally response end right at the end. And there's a shortcut called duration. So every resource also has duration, which is just a shortcut of response end minus start time. Right? So most times we just care about that. We want to know how long it took. Sometimes we care about duration and start time because we want to know where it started. But if you're doing further debugging, then the whole waterfall helps. Right. So that's essentially it. It's actually pretty short code there. The rest of it is all support code and then something to go into iframes and stuff. All right.
Yeah, this is actually a simpler example, right? So what if we already know the URL that we want to measure? Then that's really kind of the easiest case as far as how you might use resource timing. So in this case, my website's super simple, right? And I already know that this is never going to change. It's a static image URL. So I don't have to go find it in the DOM or anything. I just know that that's always going to be the URL. So all I have to do is call performance.getEntriesByName and pass in the URL. And what's interesting about that is the performance entries actually is basically this array that contains a combination of resource timing entries, actually markers for the navigation timing components, right? And also the user timing, which we're going to get into. So they're all in kind of the same spot together, which is kind of cool. We'll talk about that later, about how you can actually use combinations of some of them. But in this case, I'm going to go and the resource timing entry for this is keyed off of the URL. So I just pass in the URL. And it'll return an array of everything that matches whatever it is. And in this case, I know there's just one of them. I want the first one. So I get it. And then I can go in and I can access all of those attributes that were shown in the timeline on the previous slide. So in this case, I'm constructing an object that contains some durations, right? So I wanted to see how long it took to fetch the entire object, which is the duration shortcut, as Philip pointed out. And the cool thing about the duration shortcut is it shows up as an attribute on some of the other objects, right? So everything in that performance timeline array has a duration attribute. So you can just read it out. You don't have to worry about which type it is if you're dealing with different kinds. So that's for the overall load time. Then I can actually see how long it took to look up the host name, right? So that's domain lookup n minus start. The TCP connect latency, the amount of time that I spent waiting on the first byte of the request to come back from the server, as well as the amount of time that it took to actually fetch the object, right? So once I started getting the object, how long did it take just to download the content over the network? So this is, in my opinion, I mean, this is really cool, right? This is stuff that, again, was only available by going and like natively instrumenting browsers and then running simulations. And what resource timing gives you is the ability to fetch this granularity of data off of real user traffic, regardless of where they're connecting from, when, and et cetera. So that's just a simple example. The other thing that we can do, though, oftentimes what you're interested in isn't just the performance of one object, but it's the performance of like a whole group of objects, right? So how long does it take for me to load all the Twitter stuff on my page? Or any other type of third-party content that you have that you might want to manage. So a really simple example, and this is one that actually works. You have to understand how the component is put together on your page a little bit. But what we're doing here is just really simple, right? We go through and we just get all of the entries. So if you, instead of doing get entry by name, if you just call get entries, it returns the entire array. And then we just iterate through that. And we pick out every single one of them that matches platform.twitter.com. So that's going to return all of the resource timing entries for anything that was associated with that host name for the Twitter widget in this case, right? So if it's a match on that, then we go and we find the first and the last object in that series of objects. And then we take the start time from the first object, and we take the response end from the last object. And the distance between those two is the amount of time that it took to load that entire component. So I could then take that, and I could return that piece of information back, maybe with some other third parties as well, right? Because, I mean, what is it, 16 different host names on average, I think, according to HTTP archive in pages. So if you figure out what that means in terms of actual contributor groups of third parties, it's still a pretty good number. So you can send all of those back along with the overall page load time, and now you have more information, right? You're getting beyond just the page level, man, it took like 15 seconds to load that page, what went wrong? It wasn't DNS, it wasn't TCP, it wasn't backend, it was something on the front end, but what was it? So now you can actually return information about not just single objects, but collections of objects in a way that's meaningful, right? So if, for example, it's a third-party add component or some piece of functionality that you get from a third party that adds some social feature or engagement feature to your site, if that's the one that's causing you a problem, you might want to take up that issue with the vendor or maybe consider removing it from your site completely.
So we have a working example of this.
Oh, cool. Yeah, you want to show that one?
Yeah, we actually have a working example, and if you got the code from GitHub, you can see it there. It's the measuring a widget one. So this one has a Twitter widget, and it tells us Twitter took 1.1 seconds to load up and included all of these resources. So this was a little, so the one we have in the slides is a little simplified version because it would actually fit in the slides. And the actual code is a little more complicated because what Twitter does is it creates an iframe and then loads content into the iframe. So we first pulled out all the resources on the main page, then went into the iframe, pulled out those resources too, and then did first to last, including all of those resources. So it was not, the logic was the same, it was just a longer piece of code to do this. And if you get the code from GitHub, you can see what it looks like. So a lot of resources, most of them images, they're coming from this twimg.com, which I think is their CDN. It will be interesting to see if they actually have the CORS header, right?
Yeah.
So they don't actually have a CORS header on Twitter on widgets.js, which is interesting. So just an example of what those, well, that's a bad choice. Yeah. Various resources, what they look like. All right. Anyway, let's get back to the presentation.
All right, so that brings us to user timing, right? So there's a lot that you can do with resource timing, but it's focused on objects in your page, right? But there are other things that you might be interested in that might involve objects that get downloaded, or it might not. So the idea with user timing was to create a more general purpose mechanism for putting markers in your page. And those markers and events might be driven by the completion of downloading an individual object, or they might be driven by the completion of the execution of some really complicated piece of JavaScript code that's doing rendering in your page. Imagine like if you're a game, you have a game or something like that that's doing super complicated stuff, or you just have a lot of framework code that needs to initialize. Whatever it is, right?
Yeah, it could also be just measuring above the full time, or measuring how much that right panel or something took to load.
Right. So instead of having to key off of objects or page events, you can basically create your own events and then jam those markers into that performance timeline. Now that it's there, you can access it and you can compute deltas between those events and other things that are important that happen in the system. So it's a really powerful tool with a really simple interface because everything is keyed around these marks and measures. And the availability for user timing, and by the way, the screen caps over here is for caniuse.net. It's really easy to just go over there and search for stuff. So there's the matrix of availability for user timing. Again, recent IE, Chrome, and Opera, and the mobile devices, but not in Firefox and not in Safari. But here's an example of how you can use it. And you can come up with lots of creative ways to use this API. But just a couple simple examples. The first thing that we do up here is we basically create a start marker, right? So it's going to show up in the performance timeline with a key of mark_start. And then that set timeout was just to basically create a sleep for 1 second. So when that timeout completes and this function runs, we throw another mark in the performance timeline for mark end. So that's going to be approximately 1 second after the start marker. So if something happened that maybe we didn't know how long it was going to take, but we would like to know, then we can do the start at the beginning, the end after it's complete. And then when we want to take that measure, you just call window.performance.measure. And we give it another key. So we're creating a new performance timeline entry. This one we're calling, it's a little bit long, but measure time to this point, right? Actually, I take that back. That's not the one. So there's two different ways to do this, right? If you call window.performance.measure, measure time to this point with no parameters, then what it does is it measures from navigation start, right? Yep. So from navigation start up to that point. So how long did it take from where the page started loading until I got here, right? So that's a useful one for above the fold time, for example. If you know when that occurs in the page, you can throw a measure, in this case, in there that will compute the delta between that point and when the page started. And then you can come back and refer to it later. Or you can create distances between two things that happen inside the timeline. And that's what I was getting at earlier. So that one is, we're creating one called measure_duration. And we're taking that as the distance between that mark start event that we created and the mark end event. And once that's in there, then we can access it the same way we access the other stuff. So we're doing performance.getEntries by name, passing in the name of the key that we want. It's going to pass back a list. So in this case, we're taking the first one and calling duration on it because, again, they all support duration. So you can access that, and then you could, in this case, we're just logging it as an example to the console, but obviously the point would be to pass it back on something like a Boomerang JS beacon so that you could collect a bunch of these and then draw insights from it.
So an interesting experiment, if you want to try this out, try this kind of an example with a small timeout, so something like, let's say, 50 milliseconds, and see if the difference actually matches 50 milliseconds or not. So you'll know whether your JavaScript timer is actually running at that same resolution or not. Right? One of the reasons why user timing is so cool and exciting for someone like me who writes Boomerang is I no longer need to wait for Boomerang to load before I can start measuring. Right? Page developers can start doing their measurements, can start creating marks anywhere in the page, even before Boomerang has loaded onto the page. And once Boomerang is loaded, it can just pull out all the marks that have already been created and send that back to analytic system.
And you know, the one that we didn't include in here in our list was the high resolution timer.
Oh, yeah.
So the cool thing about this too is you're not limited to measuring at millisecond precision. You can get nanosecond precision, which again, if you're doing things that don't involve network activity, maybe they involve render activity, just run in routines that you want to do some profiling on in your JavaScript, then you can use this for that as well.
Right. So I'm going to try and open that console tab again. All right. I think that's called performance.now if anybody wants to try it out.
Yep.
Sorry. So performance.now, it actually gives us a wall time, so time from navigation start until now, the number of milliseconds dot nanoseconds that have happened. So it's pretty high resolution, something that you cannot get from, for example, the new way of doing this is date.now. Right, that's milliseconds since the epoch. So the two are kind of different, but depending on what you want, and you probably often want this. Oh, timing, right? Sorry, I sometimes just decide to live code. So where were we? User timing, example. And this is probably going to wait about 3 seconds because I have a timeout there, but all of the resources on the page, and right at the end, I have a few timers here. So top, second, third. Who hasn't downloaded the source code yet? All right. Either everyone else is lying, or they know how this works. I can check how many downloads happen, right? So this one's actually using Boomerang, and before I do that, we're gonna look at Boomerang timing. So, like I said, I work on Boomerang, and one of the cool things is so we now can get all of this data without doing a lot of hacking around. So previously we'd set a timer on unload, and then check the time on onload and figure out how long it took, and we had some hacks to figure out when was the first byte time and stuff. We still need to do that for Safari and IE 8 and older, but let's hope Safari changes and IE 8 and older disappear. But these are all the timings we get out of Boomerang now, just using the navigation timing plugin. Then there's the resource timing plugin, which I think in the next day or so is also going to go into iframes. So we'll not just get all the resources on the page, but all the resources inside all the iframes that are on the page, and nesting as far as necessary. Obviously makes a very large beacon, but we get all of that. I don't know why Chrome extension shows up. Anyone? Pat? No idea. Sorry? Surely a bug in Chrome. I don't know. Chrome doesn't have bugs, does it? So this is using Boomerang, and the way to do that is actually to just load boomerang.js, navtiming.js, and restiming.js, or if you actually know your performance work, you'll combine and minify those into a single JavaScript file. And it does pretty much everything else for you. So if all you did was include those 3 files on your page, it would do all these measurements, and when the onload event fires, send a beacon back to your server, assuming you configured it to send a beacon to your server. We have the rest of this code is actually just to draw that little pre-tag with all of the results in it. So all of this does nothing useful on the page except display a div. So one thing that we wanted to do, and I wanted to actually write that here, was write a user timing plugin for Boomerang. So I did that this morning. And that's pretty much as big as it is. So it's a fairly short plugin. I'll probably get it into Boomerang's GitHub later tonight. But essentially, run through all the marks and measures, and you can configure it telling it which marks and measures you care about. So collect all of those and send it back to your server. The code's getting a little more complicated. So if anyone has questions about the code, feel free to put your hand up and ask. We're happy to answer any questions. Right? So here, what we do first is run through all entries by type mark. And if it's something that we care about, add it to the variable. Once we're done with that, go through everything that's a measure and add that as well. So a good question is, what happens if you have the same name for a mark and a measure, right? My code will probably overwrite marks with measures. But I'm accepting patches.
All the stuff that we talked about is about getting beyond page level metrics, meaning how do we drill down in the page, right? How do we get object level data? How do we get information that maybe doesn't pertain to objects, but it pertains to things that happened inside the page because of execution of complex code or whatever. The other thing, though, is that you can moving beyond page level metrics, at least to me, means also getting beyond using real user measurement just for measuring technical stuff, right? Because you have access to all these other things that people are doing in RUM. So you can use JavaScript, Boomerang.js, any of the APIs and everything, and while you're batching all that information up, you may as well collect some information at the same time of how all of those things, how the third-party components, the page-level stuff, how long all of that's actually affecting the behavior of the user on your page. And the way that we look at it is that managing performance of your site is really a three-step process, right? The first one, obviously, is the step where you baseline the performance of your site. And then the next thing that you have to do, once you know how fast you are, is to figure out how fast you actually are trying to be, right? What's your goal? And then the third one is, how do I get there? And one of the things that I've always been struck by is that we provide a lot of tools to answer the first part and the third part, but not so much information about the second part, right? And I think for most of us, we just kind of take it as a basic tenet of faith that faster is always better. But sooner or later in your organization, whether you're a commercial company or you're a nonprofit or anything else, you have to prioritize this type of work against everything else. So it's helpful to get some metrics, if possible, around how fast you actually should be and why you're trying to achieve that particular speed. So that, to me, is a big piece, right? It's something that I think there hasn't been a lot of research done in this area outside of individual point ones. There have been some really interesting talks in the past where people would say, for my site, 200 milliseconds equals this happens, right? Or if users wait longer than 4 seconds for pages to load, then this other horrible thing happens. But what we wanted to do was figure out if there was a way to use information that we collect about the performance of pages and the performance of other things in order to kind of turn this into almost like a formula, right? Or at least a methodology or a process that people can use in order to answer the question of how fast they should be. And so to us, the first thing that you have to do is identify what it actually is that matters to you, right? So, okay, we're collecting all this information about speed, but to what end? What are we trying to get people to do? Are we trying to get them to buy and commit orders or to engage in the content in some way, click share, like something, comment on an article, just generate page views, right? If you're in media and ad impressions is really big, then that's probably a metric that you track already in addition to all the performance data. But again, the other thing that always kind of struck me is the fact that we collect all this, we spend all this time collecting performance information by itself over here. And then there are all these other tools like Omniture and Google Analytics is actually been really good about including some of the performance information, but traditionally has been very focused on collecting, and continues to be on collecting the behavioral information, but not a lot of things that bring those two things together. And so I think people over the years have seen this kind of chart, right? And this is something that we're really big on evangelizing that people do with real user measurement. So as you move beyond just collecting speed metrics with RUM data, actually start to look at how you can collect behavioral metrics as well, put them in the same place, and then start drawing lines in between those two things so that you can answer that, among other things, answer that second question of how fast you should actually be. So what we're looking at here is doing that, right? So the y-axis is a behavior. In this case, it's a conversion rate on orders. So, we always look at conversion rates and bounce rates and everything. I think there's this tendency to look at them as this one global number. So the conversion rate for your entire site's 2%, or the bounce rate for your entire site's 30%. But the reality is, I think this is really interesting. You can take all of the page loads, or we actually look at session data, right? So all the visits that happen on your site, and organize them into buckets by speed. And then when you do that, you can see how that other behavioral metric changes depending on the performance that people are seeing. Because the reality is that no matter how good or bad, fast or slow your website is, the truth is you're delivering good and bad experiences to people at the same time, right? So that's exactly what we did. We took that into account in this chart. And this is something that we see true with every site that we work with, and organized it. You could do this any way you want with Hadoop or with a commercial product, or I don't know if you could do it in Excel with a lot of data, but anyway, organize it into this kind of what's essentially a histogram. And we find that the slower the website gets, the lower the conversion rate is. And that's intuitive, right? I think everybody gets that. But what I think is interesting is not just that the correlation exists, but that we can measure the correlation, the extent to which it exists. And that means that we can actually measure patience, right? So if we can measure patience, then we can manage it. So here's an example from one site that's a big e-commerce site. We looked at a month's worth of data, okay? And the median load time for that site was 4.12 seconds. So in this example, site gets 25 million visits over the course of that month. Its conversion rate is 2.71%, right? And the other thing that you can collect with real user measurement, right, in addition to all the performance information, you can collect information about whether they stay on your site, whether they convert. You can also collect information like, if they convert, how much money did they spend? Or just, in this case, what is the typical order, right? What's the average value of an order? So average order value in this example case is $100. Okay, so the question is, can we do better than the 2.71% conversion rate that we saw? And it turns out that we can, right? Because we can basically just look up the best case on this chart. So we go over to the point where the conversion rate is at its highest, which it happens to be at 3 seconds. And the conversion rate there is 4.88%. So that means, and by the way, there were hundreds of thousands of visits in that bucket, right? So it wasn't just a really thin sample. There was a fair amount of traffic that we looked at in this case. So we know that it's possible to achieve a 4.88% conversion rate, even though the reality, if you look at all of the visits that passed through this site, was 2.71. So we know several things, and this is the importance of collecting information beyond just page-level metrics, right? Collecting, and even beyond just operational timing metrics, but collecting behavior metrics. Because now that we have all that stuff in one spot, we can start to plug things into equations and see what our potential is. So again, what are we playing for? We have 2.71% current. 4.88 is what we know is possible. In this case, it's at 3 seconds. So the gap between those two is 2.32%. Now, there's a 2.32% conversion gap and 25 million visits and an average value on an order of $100. So you take the difference, the 4.88 minus 2.71, multiply it by the 25 million visits, multiply that by the average order value, and you get back $54.25 million that were potential, that could have been captured by this particular website, except it wasn't because of performance. Because the only thing that changed in the chart that we were looking at was the performance of the website. That's the problem with, I think, doing before and after performance and making an argument that you need to speed up your website because it was here last week and it's faster this week, and oh, by the way, like your behavioral metrics changed. It just means that there's going to be all these other uncertainties, right? So what else changed between last week and this week? So I think a good way to control for that is to organize everything in a histogram instead of looking at time series data. And so when you do that, you're controlling for as much as you possibly can in isolating just the variable of performance, because that's the cohort that you split everything into. So what you arrive at is this number, or I think if I was going to make this case to like, you know, a bunch of business people or senior executives or something, I would just say it this way, right? 1 second equals $54 million. The reality is it's 4.12 and 3 seconds was the target, but who's counting, right? So 1 second equals $54 million. So I think that's pretty cool that you can use JavaScript, basically, to figure out the answers to these kinds of questions. And then, at the same time, collect all this object-level data that allows you to then go in and actually say, okay, great, you know, this is what we want, so how do we get there? Oh, by the way, these third parties are slow, and you know, these objects are synchronous, and et cetera, and then go fix the problem. Except there's a caveat there, right? It's a little oversimplified. So what's implied there is, you know, we said that we were going to move everything over to 3 seconds for page load times. That kind of implies that everyone gets 3-second page load times, right? So in other words, we're saying that if we make the 100th percentile 3 seconds, which is impossible, right? Like it's impossible to give everybody the exact same experience. Then you could make all this, you know, all this money or whatever it is. By the way, it doesn't have to be dollars. It could be, you know, petition signings or whatever it is that you're trying to get people to do. So let's go back and revisit this for a second and see if we can refine it a little bit and make it a little bit more pragmatic. So what we did is we said, well, what if from trying to go from 4.12 to 3 seconds, what if we said, you know what, we just want to focus on 4 seconds because it's close in, right? It's close to the 4.12, which, by the way, happens to be the 49th percentile, right? So the 50th percentile for this site was 4.12. The 49th percentile was 4 flat. Okay, so, and then if instead of shooting for this unrealistic 100th percentile, what if we said, you know, we're going to aim for the 60th percentile? Okay, so we'll move from the median, or 50th, up to the 60th. So if we take the 60 minus the 49, right, what we're implying is that everyone on the other side of 49 already has achieved the load time goal, so they're not eligible for this optimization. Everyone on the other side of 60, for us right now, is unrealistic. We're targeting basically kind of this band in between 49 and 60. So that's an 11-point percentile gap. So once we do that, then we can go back and we can reapply the same kind of math, right? Except we're taking the 4.88 minus 2.71, which gives us our conversion rate potential. And we're actually filtering the 25 million total visits by the 11% that we're actually targeting, okay? And then once we do that, we take that remaining percentage of visits that is our targets for conversion, and we apply that to the value that we associate with a conversion. So in this case, the value we associate with a conversion is $100. So we get 6 million. So that's pretty cool, right? Because it implies that if you go from 4.12 seconds at the median to just kind of like this fairly modest 4 seconds at the 60th percentile, that you could increase the revenue over that month and in subsequent months by $6 million. So once you've done that, I think it's what we found is that it creates a pretty compelling call to action. That's one of the struggles that over the years I've often bumped into, is getting people to believe what I believe, which is that speeding up your website has really fundamental and important and meaningful impacts to your website in terms of what you're trying to get your users to do. So what this enables you to do is basically use JavaScript and real user measurement to measure that information, put it in context with speed, and then figure that out.
Yeah, you also get to, I get this more examples.
Oh, more examples, sorry. Yeah,
just getting to that, you also get to decide whether you trade off between features and speed, right? So if you have a particular feature that's bound to improve sales, but it's also going to reduce increase load time, is it worth putting that feature in or not? These kind of calculations can actually tell you that. Right. So who wants to volunteer a site to test on? I'm just going to, if not, I'll look at the Velocity site. All right, so performance. So just some live coding to see what happens when we do this, right? So I do performance.get entries by type and get a whole bunch of resources, right? This is what it typically looks like. So this is something running on the CDN. So we can see zeros for everything there, duration 4.5 milliseconds, the time it actually started, and the time it ended. Now, if there's something from the origin, let's see. Is everything loaded from the CDN? That's the waterfall. All right. This one's loaded from O'Reilly.com. All right. So it'll be interesting to see what happens when we have timing allow origin. So I'm going to go to the log normal blog, which does actually have resources that use this. I don't know why it's going there. All right. So just one example, that this is a resource that has the timing allow origin star. So it's coming from a different domain, c.goimpulse.net versus our page's domain, which is lognormal.com. Right. And if I look at that, I should actually see full timings for it. So Google Analytics does not have that header versus lognormal.net also does not have it. Oh, I know what happened. It's in an iframe.
Oh, is that the async script loader pattern?
Yeah. All right, there we are. So this is an iframe. We can verify that the domain is different. So the domain of the iframe is lognormal.com. The resource is on goimpulse.net. But because we have that timing allow origin, we have all of the time. So we know what time the connection started, what time how long it took to do a DNS lookup, etc. Right. So if we wanted to look at the whole widget, so the Boomerang JavaScript and all the scripts it loaded, we'd take these two and get the difference between the two. Right. So that kind of helps us decide whether a particular widget or a particular vendor is causing problems. Yeah.
Does each document get that set of entries?
Yes. So that's a good question. Does each document get its own set of entries? And yes, every iframe, so every document object within every iframe, does have its own set of entries. You do need to call window.getEntries on each frame to get that list. So if you're looking for your everything within the page, what you'd actually do is get all the resources on the page, then get all the frames on the page, go into that, get all the resources within those frames, and keep going down as far as necessary. Yes?
Back to the question. So I just looked in the HP archive
Yeah.
over the last 6 months, the percentage of requests that have the timing allow origin has increased from 1% to 5%.
That's cool. So let me repeat that for everyone. So a fact that the percentage of requests with a timing allow origin has increased from 1% to 5%, right? In the last 6 months.
And that's as measured by HTTP Archive. So you can go to httparchive.org and track that as it changes over time.
But 5% is still pretty And I would expect that when you go out to customers who want this, they're probably using a CDN on a different domain or
Yep.
a capital mark. Do you usually have to go through a step where you get them to add timing allow origin?
So we as a third-party script author will always, I'll repeat the question. So the question is when we talk to people who want to do this kind of measurement on their sites, and they typically have a CDN, do we need to tell them about adding this header to their CDN so that they can measure their own timings, right? Is that? So we typically do recommend that yes, when you control your site and you have your own CDN host name, so you may not actually run your own CDN, right? Who runs their own CDN here? All right. A couple of guys, they must work at Akamai, Fastly. But if you don't, which you most likely don't, you might still have a dedicated host name for your CDN. So like O'Reilly has O'Reilly static.net or something, and it's typically a CNAME to your CDN provider. But what you can do is for that host name, all requests that come in for that host name, put in a timing allow origin for your origin host name. So we'd put in timing allow origin velocityconf.com only on the CDN that serves O'Reilly. Now, if you're a third-party author like me or Google Analytics or Facebook widget, for example, you probably want to put timing allow origin star so that all of your customers can measure you and hold you to an SLA. Maybe you don't want to, but we are saying that we'll do that, so we think all other third-party script authors should do that and be accountable for how long they take to load.
We have locales whose conversion rate is much lower and their performance rate is much lower, but it's not, I mean, we just don't sell as much there.
Mm-hmm.
And it's also, they're distant. So do you have tricks for disambiguating that? In your example, I think it would sort of trip over that.
Yeah, it actually, so we gave a talk at Velocity a few years ago where we got into that in a little bit of detail. We talked about how it might change depending on the locale that you're in. So one of the things that you can do that we didn't get into with the way that you actually do the analytics and chart everything is that you can split that information across dimensions if you want, right? So when you create that goal and you do all the math, you don't have to just kick out one number. You might kick out a different number in different geographies to account for different things. One of the things that we've found in the past, for example, is that all other things being equal, typically something we often see is that for any given load time, the bounce rate in Australia is less than the bounce rate in like the United States and the UK. Which was interesting. We talked to some folks from Australia who said, dude, you have any idea how slow the internet is in Australia? Yeah, of course we're patient, right? Like everything is slow. So it's not just your site. And therefore, that means that the load time that you need in order to achieve a particular behavioral goal you might be able to tolerate more slowness. And in fact, you might have to tolerate a little bit more slowness in certain locales and in other locales. But the way to find out is to do that type of analysis and do it split out by different dimensions that matter to you. So you might do it, obviously, you could do it split out by different web properties if you have more than one property. You could also do it split by different regions. That's another popular one that shows up. Something that we haven't seen, we thought it would be cool if like IE users were more patient than Chrome users or something like that, but we didn't find that to be true.
Well, we found some difference. It turned out that it's just a difference in when the first paint happens. So it's not that the users are more patient, it's just that page appeared to show up more faster in one browser versus the other. We're not going to say which is which.
Yeah.
We also found things that when a user is doing something that they find interesting or pleasurable, they tend to be more patient than when users are doing something they find frustrating. So, for example, we looked at web traffic during a particular sports event and compared users from the two countries that were playing. And every time a goal was scored, the country that scored the goal, users tended to become more patient versus the other country that actually got less patient was less tolerant of errors. So, for example, we saw right at the start of the game, one of the countries had a 80% intolerance for errors versus the other that had 50%. But when that first team started scoring, their tolerance for errors went up. They were more likely to refresh on a 400 or a 500 page versus the other team, and so on. So it's the same page. The performance of the page isn't really changing much. It's just what's happening at that point of time is changing. So the user's perception of 3 seconds changes.
We've also found that it changes depending on the type of products. Like take e-commerce, for example, right? So if you look at a company that sells products that are highly competitive, like you can buy it from Walmart, you can buy it from Amazon, you can buy it from all these other places, then they might be a little less tolerant. What we've seen is that they tend to be less tolerant of performance issues because the switching cost is so low, right? It's so easy to go somewhere else and just do the same thing on a faster website. On the other hand, if it's a website where like the only way to do this one thing is on this website, then those users tend to be more patient because you sort of have a monopoly on what that one thing is, right? So their choice isn't get it from this site or get it from that site. Their choice is to get it from this site or do without. And that changes people's, maybe not their perception of speed, but it changes their patience levels with respect to what they're willing to tolerate and still go through and complete the process. And it's one of the reasons why we think that, especially now that the browser technologies and everything have really kind of made this so accessible to people to collect information, it's important to do your own homework and not go off of what's true for another site, because even if it's in the same space as you, it might not necessarily be true for your users.
Right.
Anything else?
To that last point, how do you separate users who come back later from users who never come back?
So the question is, how do you separate users who come back later from users who never come back? And I think most sites already know when they have returning users, because you have, you track your users in various ways, right? You have user accounts probably. You know if somebody's coming back. Even if it's a non-logged in user, you'd typically have a cookie so you know that this is a returning user or not. So we can piggyback off any of that information, right? If you as a site owner know if a user's coming back, then you can just correlate your information with that. If you don't, then it's probably time to start measuring that. So cookies are the best way to measure it. Some countries don't allow cookies or need you to be very clear about what cookies you're setting. So within the laws allowed, you can track some things and you cannot track other things.
And that is an area that, Philip, you and I discussed. I know, there's really two major things that we covered in the talk, right? One is getting beyond page level metrics and drilling down into objects. The other one is, drilling into user behavior in the scope of a single session. But that's another thing that you can do with real user measurement that I think there's a lot of work left to do and a lot of interesting research, and that's how speed affects lifetime customer value or the likelihood of somebody coming back and actually doing or interacting with that website again. I know that Google and Bing did some really interesting studies about where they actually intentionally slowed down search results and measured how that impacted someone's likelihood to complete searches, come back and search again, and saw that even in their case, at their scale, modest differences in load time that they intentionally introduced had statistically significant and measurable impacts on user behavior. So if that's true with something like a search engine, then I think it would be true for other types of sites as well.
So the question is, why don't we just bake into Boomerang things like time to first scroll, time to first mouse move, time to first click, maybe first key press, etc. That's definitely something we've been going back and forth on. One of the reasons is we don't want to interfere with the page itself. So a lot of pages might already have events attached for that, and we could do that in a transparent way, but there's still some amount of research going on in that area. Figure out. The thing is, we don't want to break any site. It's not like we can afford to break 0.1% of sites. So once we figure that out, we'll probably do that.
Yeah, I mean, I guess if it showed up, it would be in a plugin, right? So
yeah.
you could build it in or not build it in, depending on your
exactly.
site, right?
So building Boomerang plugins is actually fairly easy. You saw the user timing plugin I wrote. It took me about 20 minutes. That's probably because I've been writing plugins for a while now, but it's actually not that hard to write plugins. If you want to measure something, the only thing you need to do for a Boomerang plugin is to add that thing that you're going to measure onto the beacon. Boomerang takes care of calling your plugin at the right time and stuff, so you can call it when the user scrolls. Typically, I think when you attach to the on-scroll event, you want to take off the event handler after the scroll, right? Otherwise, it tends to affect performance a lot. So the thing you don't want to do is have your performance measuring tool cause performance degradation. I think many years ago, I saw a performance measuring tool that attached an on-click event to every link on the page. And it took about 4 seconds to go through that. So you'd have to wait for the tool to finish instrumenting the page before you could use the page. So we don't want to be that tool.
One in the back.
Right.
Any tips for how to instrument SPA applications or something that doesn't hit the page?
Single page applications?
Yeah, Angular.
Right. So the question is, any tips on how to instrument single page applications or applications that use Angular? You've tackled this a bit. And so I'll talk a little bit about ideas that we have. One of the things you could do is proxy the XML HTTP request object. So you put a wrapper around that and just measure start and end. So every time requests are happening, you could also allow a developer to instrument it. So using Boomerang, for example, Boomerang has a request start and response end method. So you could, for example, through your XHR calls, call out to Boomerang saying this is when a request is started, this is when it's completed, so measure these particular events. Or, yeah, that's what I was getting to. You could also use user timing and just set a time, a start time and an end time whenever that happened. All of this requires you as a page developer to actually add code to your page to measure these things. But like I said, an automated way would be to just wrap the XML HTTP request object or the XDR object and automatically collect that. One issue with that is every time we wrap these built-in objects, we could be affecting performance. And if a site had 2 or 3 different RUM libraries and all of them did that, you'd actually have a wrapper around a wrapper around a wrapper. So it's not the best way to go forward. But if you're running your own site and you know that you're the only person measuring it, I'd say that's a good way forward.
Yeah, and I think that's a case where, again, moving beyond navigation timing and looking at some of the more recent APIs is even more important when you have a single-page application, because the navigation timing piece is done after you've loaded the framework, right? You're not going to get more information out of that. So looking at the other stuff that lands in the performance timeline, namely user timing, and also looking at objects that come in through resource timing if you're adding HTML fragments and things in your page that trigger downloads. And also, by the way, we didn't look at every single method call in all the APIs. You can clear all of those marks and measures as you go. So if you want to keep things simple and you're running your application, when you do stuff, and then when you get done with your XHR or whatever the batch is that delivered the next screen, if you will, then you can go through and clear all of those out so that you have a clean array for picking up the next stuff. But I think in that case, the browser is doing less for you, so you have to do a little bit more, work a little bit harder with your instrumentation logic.
Yeah, one thing we didn't mention, so all XHR calls actually do show up in the resource timing list. So if you do get entries by type resource after your XHR call is returned, you'll get those entries in there as well. So you could look up all of the timing information from that as well. So the question is, how is the Beacon API going to affect the way we currently do this with Boomerang? So let me explain how we do this with Boomerang right now. So what Boomerang does is it creates an image and assigns a URL to that. So the browser will make a GET request to that URL, and that sends all the data over the wire. Now, if the data is too large, then Boomerang will actually create a form and add the data as post data and do a form that's submit. So it takes care of that. The Beacon API is a way for browsers to actually do this for you, so you don't need to hack around this, create an image or create a form. You can just say, this is something I want to beacon. It also takes care of, for example, sending a beacon when the page is unloading, which is not very reliable using JavaScript. So you don't necessarily know all the JavaScript that might execute in the unload event, right? Especially if you have asynchronous JavaScript, some of it might execute and some of it might not. So the beacon API is supposed to fix all of that. However, it's going to be a while before all browsers support it. And I don't think we can get away from the ways we're sending beacons right now. It would be an add-on. So let's do this if it's available and fall back to these if it's not.
So any recommendations you can make for actually storing all this information and also analyzing it?
Right. So the question is, any recommendations for storing all of this information and analyzing it? So there are different ways of doing it depending on how large or how small your site is. There is an open source server called Boomcatch that collects boomerang data, so you can use that along with something like StatsD or MySQL database or whatever you like as a database server. So that would collect data and put it in there. You could pay us to do it for you. There are a bunch of other companies that offer commercial products to actually collect and analyze this data. When I first started this out, I was crawling HTTP access logs every hour or so. So I rotate my logs every hour, collect the rotated logs, run a Perl script on it. I would pull out data and insert it into the database. So I had about 3-hour latency, which was fine because I had 300 hits a day. But that doesn't quite work when you're dealing with 300,000 hits a day or 3 million hits a day.
You know, there's just FYI, there's also a free version of the product that we sell. If you go to our webpage and there's like a free button, and you can go over there and it'll show you where that stuff is.
Right. Well, did that answer your question?
Yes.
Yeah, all right. Right. So that's a good question. So the question is, if the user comes to your site, and let's say it's their first page load, and it takes a long time to load, so they leave the page before it's completed loading, we're not actually measuring that because the beacon's not being sent until onload. Boomerang gets around that because we will fire on the first of onload or unload, whichever fires. And if unload fires before onload, we will measure that as an abort unless they happen to click on a link to the same domain. So it'll measure page aborts, and you know that this person left the page after so much time, and it had not completed loading at that point of time. Right, another question. So the question is, if the beacon API isn't supported, how do we send a beacon on the unload? Well, we don't send it on unload, we send it on before unload, which fires before the unload happens. So you can do a GET request, you can do a synchronous POST request on before unload. So some interesting things about the unload events in a browser. On before unload fires when before the page starts getting unloaded from memory. So your page is still visible on screen at that point of time. Versus the unload event, which actually fires on the first byte of the next page that's going to load. So at that point of time, the page has already been cleared off the screen. The request for the next page has already been made, and the first byte has come through. So on browsers like Safari, for example, you can use that as a proxy for time to first byte. Did that answer the question? Anything else?
Oh, this one over there.
So the question is, any guidance for high traffic sites on sample size? And I would say 100% because, and I'll explain why. So if you just care about your overall performance of your site, saying my site took 3 seconds to load on median, then yeah, you can do it with 1%. I know at Yahoo, for search, for example, we would have done 0.1%. But we're seeing more and more sites where they care not just about the overall performance, but what was the performance of this particular page for users from this particular region of the world using this particular browser in this A/B test, right? So you're doing A/B testing and all of that. So combining all of those dimensions, you still want a large enough sample for all of those dimensions. So what we'd like to do is we look at all the data from that, calculate a margin of error based on the sample that you got, the distribution you've got, and then decide, all right, are we within a 5% error, within a 3% error, what's acceptable? And then that's how you decide your sample size. So you can start reducing your sample if you think I'm at 1% error and I can tolerate a 5% error. Okay, you can reduce your sample at that point. But wait till you've got to all the dimensions you care about. Right?
Yeah, I think and the question was about sampling, by the way. It's, how do you approach sampling with extremely high volume, high traffic sites? And the problem with sampling is it works really great when you know all the questions in advance that you want to ask, because you can work out how much data you need in order to answer that question with an acceptable margin of error. But like Philip was talking about, oftentimes what happens with performance work is you have a question, you answer it, and that immediately leads to the next set of questions, right? And if you haven't pre-established that you need the correct amount of data to handle this like four-way intersection of different dimensions that you want to slice by, then you might find out that you're running out of data. So, if possible, don't sample. Collect all the information, so that way you'll run out of users before you run out of sample data, right? If you have to, then I think what you should do, and insist on using methodologies and tools and everything that will show you this, is just be aware of what the margin of error is. Because the worst thing to do is to say, absolutely, right, this is taking 4 seconds, but it's like plus or minus 5 seconds, right? Because the data is so variable. So you have to just be aware of what the margin of error is if you're put in a situation where you have to.
So one very quick way of reducing your margin of error to 0 is to have only one sample.
It's true.
I had like amazing margin of errors on my website for a long time because I was the only user.
Have you attempted to measure bandwidth, effective bandwidth, and network latency using this?
So I got the first part of your question. Have we attempted to measure effective bandwidth? And what was the second part? Network latency. So have we? Yes. And Boomerang does have a plugin, bandwidth plugin, that will measure effective bandwidth and latency from a user's location to the host that you host your resources on. So the way it works is we host images of increasing size on a particular server, and typically we recommend that our customers put it on the server that they want to measure the bandwidth to. And then we start downloading images. So the first thing we do is download a 0-byte, well, actually a 32-byte GIF. We download that 10 times. And that tells us latency because a 32-byte GIF fits in a single TCP packet. So that tells us HTTP latency. That also effectively increases the initial congestion window size to a point where we know that any larger image is going to saturate the network. So then start downloading images of increasing size until one of them times out. And by timeout, we mean it takes more than 1.2 seconds to load. And at that point, then we reload that same image 3 times, take the median of those 3 or 5 times, you can configure it. And that divided by the time, the size of that image divided by time is approximately your effective bandwidth. Well, we call it network throughput. Bandwidth is kind of the wrong word for that. Does that answer the question? That's all documented on the Boomerang documents, so feel free to read it, and it's in much more detail than what I just mentioned.
Yeah, and that's on the, I think we're coming up on the end of our time.
Yeah.
But that's on the...
www.lognormal.com/boomerang/doc.
Wait, not that one. That one.
Yeah.
Great. So thanks very much for the time, everybody.